systems installed inside of these greenhouses in several places, one in Alberta and two in British Columbia. I personally do not have one of these systems in my own greenhouse, again, because it's not buried into the ground. And so my hope is that these systems that I've gone and looked at will be documenting their successes and their failures in a scientific way so that we can actually determine if they're a valid approach to storing heat both diurnally and seasonally. So subterranean heating and cooling systems basically use air and pipes underground, and they run on a fan and a thermostat that basically turn on as soon as the air temperature in the greenhouse goes beyond a certain temperature to store heat using air underground. And then they use the same thermostat, so it's actually a dual temperature thermostat, to turn the system back on when the greenhouse gets below a certain temperature to pump heat out of the ground and back up into the greenhouse. So it's used for both heating and for cooling. And if you think about it, the cooling methodology or purpose of the subterranean heating and cooling system is actually heat storage, and the heating is heat exchange, so we're actually pulling heat out. Now there's a couple of other things that occur in one of these subterranean heating and cooling systems. So imagine you've got a greenhouse that's 24 plus degrees Celsius and 80% humidity inside of it. In the middle of summer, it's really, really hot in there. The fan gets sent a message from the thermostat to turn on. The subterranean heating and cooling system has a duct that comes all the way to the top of the greenhouse to pull hot air and humidity down into the pipe, and then it runs it underground into a matrix of pipes. Now these pipes are ideally designed so that they have perforations in them. Now the reason they have perforations in them is that in an ideal world, that hot, humid air would move underground and cool down. Now, as a result of the cooling down as the air moves through these pipes, if that air reaches its dew point, we will end up with a phase change. Now, remember what happens with phase changes. When water changes from a gas into a liquid, it releases enormous amounts of energy. That's really what we want to occur in a subterranean heating and cooling system. So if we can successfully take hot, humid air and turn it into cool, drier air, we will deposit moisture as well as energy into the soil through the process of condensation. That air then moves through those pipes, back out into the outlet manifold, and gets recycled back up into the greenhouse. That cycle continues on until the thermostat is satisfied. So generally, a subterranean heating and cooling system will be set for 21 degrees Celsius. So as soon as the air temperature goes above 21 degrees Celsius or 72 degrees Fahrenheit, the fan turns on. As soon as it goes below 21 degrees Celsius or 72 degrees Fahrenheit, the fan turns off. And then if the greenhouse goes below 10 degrees Celsius or about 50, 55 degrees Fahrenheit, the fan will turn back on again and will pull heat out of the system. Now imagine the other scenario where we've got a greenhouse below 55 degrees Fahrenheit or 10 degrees Celsius, and the air is cool and dry. And then all of a sudden the fan turns on, and it gets pulled through the subterranean heating and cooling system through soil that's moist and warm. Again, we enter into a phase change situation where we get liquid water that's held in the soil, gets pulled into the air, so we're changing from liquid to gas, which then pulls energy out of the soil and into the air. We humidify the airstream, which now allows the air to hold more energy, and we pump it back up into the greenhouse. That's the whole theory of how a subterranean heating and cooling system works.